ये डिटेक्ट नहीं कर रहा नहीं ये यही है
So while he's fixing his laptop, one more point. So all the dev sprint coordinators, people who are going to mentor and coordinate for different projects, you are going to introduce yourself and your project to the dev sprint participants after the ending keynote. So before we start the feedback session, you are going to do that. So please, after the ending keynote, make sure that you come forward and you introduce yourself. We'll do that. So that also means all the dev sprint participants, stay back.
Good afternoon, everyone. Sticking to the schedule, now we have a talk by Sanket Saurav, who is a co-founder and Chief of the Geeks at DoSelect. He is a 50% developer and 50% designer. He loves the web and his languages of choice are Python, Go, and JavaScript. He has also spoken at more than 50 events and hackathons across the country on open source, including Python, HTML5, and web applications. He also have a rock band. So let's welcome Sanket Saurav. Thank you.
Thanks for the very generous introduction. Hello everyone, I'm Sanket. Too much introduction about me. I had all these things in the slides as well. So I have a startup called DoSelect, and we use Python and Django big time. Yeah, I like to call myself 50% developer, 50% designer because I kind of mostly do both front end and back end, and yeah, spaces over tabs all the way. So what's this talk about? It's about my learning from using Django in production over the past almost 2 years. So when I started my startup, I was just fresh out of college, and I was a complete beginner with, beginner with Django. And so what I wanted to do with this talk is kind of, put out some of my learning in these 2 years which I've gotten by being a complete noob at Django and, making some horrible design decisions, writing some utterly, unusable shit code to, kind of improving over the way, learning a lot of things from scale, learning a lot of things from how your application behaves weirdly when it goes to scale. And some obvious and non-obvious things to do when you are in the process of, scaling, when you start seeing those spikes on the traffic and you don't know, and everything breaks and you don't know where to fix it, where to start fixing it. So during that process, I've uncovered a lot of things which are not usual, which do not, come to you as common sense, and how to get a grip when your application complexity grows. When you start off with just like, so when I started building the product, it was like, so what you do is you put all your models in one file, and then 6 months later you end up like a 3,000 lines of models.py, and that's actually happened to me. So we were like completely naive about these things, and 1 year later we ended up with like 3,500 lines of code in models.py, and painstakingly I had to sacrifice my Saturday and refactor everything. So yeah, and how to not lose your mind while doing all of this. So first things first, reasons why you should probably choose Django for building a production application at all. So my first and favorite reason, so I was talking to someone yesterday as well. The pace of development is pretty fast, so you can prototype really, really fast. And then Django has some common sense design patterns, like the rest of the Python language in itself. And it is very opinionated at times, which kind of helps you at times, and it comes with batteries. So it's the right, I feel it's something that you can use when you're just getting started and not think too much about things that do not matter to you at that point of time. But then it's very easy to break out of the box when you actually need it. So after you are seeing those spikes and you know that, hey, this is not going to work, you don't actually need to rewrite the entire thing. So this is one of the things that I really like about Django. You can break out whenever you need, and it's very, very easy. It's like very convenient. And of course, the community support is great. One of the best open source communities ever that I've seen, and been mainstream long enough to be quite mature. So frameworks do not scale, of course. Applications scale. So I was having this discussion with a few developers like in a meetup in Bangalore, and there was this raging flame war between Django versus Flask versus et cetera, et cetera, et cetera. And people were arguing that what frameworks are good for scale. So I have this notion that there's no framework built for scale. You have to kind of figure out how to scale your application with the help of these frameworks, and of course break out of the box when you need it. So yeah, so that's pretty much about it. So so what I'll do is I'll pick up some topics which you might want to take care of when you are in the process of scaling. You're figuring out how to scale up, how to do things, how to make changes that you want to do, and I'll just explain some of my learning with respect to all these small things. So I'm not sure so my talk was supposed to be a kind of intermediate level talk, so I'm not sure it will be very helpful to complete beginners with Django. So how many people are there here are like completely unaware of Django? Okay, that's quite a lot. This is not going as I expected, so. Okay, so regardless, so tuning your WSGI server, use Gunicorn, it's awesome. So I'll be making some of these, statements like this because this is an opinionated talk. So use Gunicorn. We have had some really great experience with Gunicorn. But how to actually tune it? How to actually use it to its full potential? So you have to introspect your application to understand the nature of how you need to actually think about scale. So it basically depends on what exactly is your application doing at that, what exactly is the application doing? You have to figure out, is it IO intensive, the kind of things that you're doing? Is it memory intensive or something else? And depending on that, you can tune all these things. So by default, there are a lot of things which make sense. By default, the configuration has a lot of things which make sense. But at times, you want to really look at the application, see what it's doing, and then tune the configuration as you might need. So for example, the worker class. So you need to understand when to use the sync mode and when to use the async mode, right? So for normal traffic websites, sync mode works really well. Async mode is very helpful when you're just scaling up and you see those spikes. And specifically, if your application talks to a lot of other application, as in if you spend a lot of time, when the response time is indefinite as you cannot predict it. For example, if your application is making a lot of external API requests, right, then you are better off using async as compared to the sync workers. So you can use GUent, which works pretty cool. And then you can adjust parameters like the number of workers, the number of worker connections, and then keep alive. So I'll just give you an example of what happened, why keep alive is something that you might want to look at. So we run a Gunicorn behind an Nginx proxy, which is the most common use case scenario. And then we didn't kind of make it a point to tune the keep alive timeouts on the Nginx proxy and the Gunicorn. So what happened was there were some requests which were like which took more time. They were getting dropped off between the Nginx proxy and the Gunicorn WSGI server. So that's something that you want to tune after you've figured out, okay, this is what's going on behind the scenes. And there is such a thing as too many workers. So you might say that, what the heck, we'll just put in too much, a lot of RAM onto a system and, just scale the workers indefinitely. But unfortunately, that's not going to work. Typically, 6 to 12 Gunicorn workers are like enough to handle like hundreds of thousands of requests per host. But then again, that's very subjective. But you should not be, crossing that limit. More than like 12 workers is like, you should be scaling horizontally instead of vertically at that point. Because it's not just about the RAM, but other things as well. You have to scale the other components of the host as well. So you're better off, putting in a new host and scaling your load horizontally rather than vertically. Tuning the proxy server, as I was mentioning, Nginx is one of the most common sense, say, proxy servers to use with Gunicorn. It's pretty light, it's pretty cool. And mostly the default configuration of Nginx, when you set up Nginx, the worker process is set to 1. Don't do that. When you are scaling, just set it to auto, so this auto mode actually scales the number of workers depending on however many cores that you have on the machine by default. So you don't have to do that. You don't have to worry about that. And again, keep alive timeout. It's something that you are going to face sooner or later. Turn on TCP no push and TCP no delay. So these are like just some configuration parameters that you can do in the Nginx configuration. So it's very helpful when say for example the case of when you're hosting an API server, right? And the requests are very small but numerous. There's so many small bursts of requests. Then this TCP no push and no delay, if you turn these two on, then you end up saving a lot of latency, and that's pretty helpful. And of course, gzip all the things, whatever you can, because it's going to help you save a lot of bandwidth and of course latency. Measure all the things that are possible, because if you don't measure, you don't know what's going on. Measure everything that you can. Measure round trip times and segregate that on different use cases. For example, if you have an API and if you have a search engine, you should measure these two average response times separately, right? So if you don't measure, you'll never know where the bottleneck is, right? If you serve an Elasticsearch if you have an Elasticsearch search engine and you're serving that over a Python front end, and then you have the Postgres-backed API on the same front end, then you have to figure out, where exactly is your, where exactly is the latency. So yeah, so measure as much as possible because that's the only way to figure out. What's taking so long? Yeah, so Chrome Developer Tools is pretty cool when you want to figure out which of the requests are taking too much time. A few things, without going much into the details, a few things that you want to look at is TTFB, time to first byte, and then kind of correlate with what's going on your server. And this is an ongoing process. You just figure out what's taking so long, you fix it, and then rinse, repeat, do that again. Talking specifically about Django, so Django ORM is pretty cool. I'm going to talk about it in the next slides. But it's also, sometimes you should know what's going behind the scenes, right? So it's very, very easy to go wrong with Django ORM. It's very, very easy to, kind of mess everything up because it's so easy to use, right? So, so one of the things that, I would recommend is tail your, whatever database that you're using, tail those logs. Then you'll actually understand the monstrosity that's going behind, right? Whatever Django queries, ORM queries that you're doing, you'll actually know what's happening. And then you can figure out which are the queries that you should actually look into. So Postgres has this thing, explain, analyze. So you just run it over a query and it'll tell you all the details about the query, what is the mean time that it's taking, so that you can probably simplify those queries, figure out how to split this up, and so on and so forth. So I came across this very nice blog by Discuss folks like a few years ago, which basically says that how they have been using Python and Django to serve billions of requests per day, and the core underlying part, which they wanted to, the point that they wanted to make essentially was Python is most likely not the performance bottleneck in your application, right? So I've met so many people who who really like to thrash Python because hey, it's slow, but when you are building web applications, it's not where your bottleneck is. There's so many other things that if you just take care of them, the slowness of Python is not going to matter, right? So before actually going to blame everything on Python and moving to something else, you should actually look at the other things. Of course, and use caching as often as possible, and use caching very intelligently. I'm going to come back to this point later in the slides. Yes, I think it's here. So cache all that you can, but no more. Caching is very, very helpful in case of Django again. So why I'm saying this is, again, Django ORM and the way that, it's so easy to use. It's very, very easy to go wrong as well. So one of the most common sense thing to do, which if you look at it, a lot of people don't do, is cache their sessions, cache user sessions. So a lot of people still just use the database as their cache backend, which is going to hit you hard if you are scaling up the users, scaling up your users. So use Redis and cache all your sessions. Second, cache all your user model lookups. So if you're using Django ORM like big time completely, if you're not writing any raw SQL queries and your entire application uses ORM queries all over again, you are going to use user contrib-user authentication as well, right? And if you're using something like TastyPy or DRF, you're going to serve an API, and all the API authentication happens over this. So you don't actually know how many times is this query being, how many times the user model is being queried upon, right? So if you just add caching to all the user model queries, you'll end up saving a lot of resources, and your lookup time will decrease like very, very much. So that's one of the tips that it's very intuitive, but a lot of people don't do it, right? And there are a lot of pluggable Django applications which readily do this for you. So there's this application called, there's this app called Django Cache a lot, I guess. So which actually does this for you out of the box. It's a drop-in solution for this. So that is very helpful. Second is resource level caching. So if you're serving APIs, then it's good to kind of cache on the API level, because there you can do a lot of stuff. You can do rate limiting as well and all these things. So resource level caching is also going to help you when you're like serving millions of API requests. Use a CDN for all the things that users cannot change. So that is kind of a thumb rule that I follow. Most of the all contemporary applications, most of them are like in form of a single page application. So mostly you serve your front end separately, and then your back end is just an API server for your application. So in that case, don't even serve HTML from Django, right? Don't even serve anything that the user cannot change from Django. So that's like something that if you think about it, your HTML, once you have deployed that HTML, it's not going to change, right? So you better version it properly. You can use the Git SHA for versioning it, push it to a CDN, and then be done with it. So the application is never going to serve HTML, because in the end you're not compiling any HTML at all. So of course people use CDN for static files and images, which makes sense, but not a lot of people, even if they are not actually doing any HTML compilation, they're still serving it from Django views. So that is something that you should think about it. So push everything to CDN which the user cannot use. And lastly, varnish. Varnish is like, it seems like the silver bullet, but it's not. I'm not going to go very deep into varnish right now, but it's a very helpful way to kind of manage when you're scaling. So the Discuss blog actually goes to a great length to explain how they achieved so much, so how they were able to scale to so much requests using varnish at the front of their caching layer. So yeah, so coming back to the ORM is awesome, but it's not always the silver bullet. You need to know when you need to break away from the ORM. So yeah, so tail the database logs, see what your ORM queries are actually doing, and what they actually, when you do something.objects.all or something like that, what's actually happening. Maybe you don't need to query all those things. Maybe you're just using one attribute, and you're fetching the entire row. So that's something that you don't need, right? So if you have identified where your bottlenecks are, what queries are taking the most time, it's good to kind of understand what exactly can you change. Automatic relationship access can bite you. So we take a lot of things for granted when you're using Django ORM. So if you have a lot of relationships, and then you're rendering a template maybe, or you're dehydrating a resource, then a lot of things gets fetched with it, which you don't actually need. So for example, if you just need the count of, say you have a comment model attached to, say, a post. So if you just need the count of the comments, you don't actually need to fetch all the comments related to a post. But it's very easy to do that. It's very easy to fetch all the comments and then just count it. So take a look at the queries, and then you'll figure out, okay, what are these, whatever code that you're writing, whatever things that we are taking for granted, what do they actually mean? So Django has a lot of things like select related, prefetch related, which you can explore and figure out, okay, this is how it can be done in a better way. And add extra indices where needed. So most of the times the queries that you'll be writing, complex queries that you'll be writing, those will be operated on more than one column. So it'll be a good idea if you can use multiple indices on a table. And yeah, offload the heavy lifting on the database all the time. So this is something that it does not come naturally when you're using the ORM. for database access. So small things, I think I have an example here. Can you guys see it? Is it visible at the back? I don't think it's working on the small screens. So I don't know, this does not, it's not working. Okay, so basically you can write a custom manager and small things like, counts and, some calculation which you need to query upon. For example, this is a model for a test report. So a test report might contain attributes like, starting time and end time. Now, when you're generating the leaderboard, you need to sort on the time taken. Like the person who has taken the least time, they should be on top, right? So instead of doing that calculation on, in Python, you can make use of the database functions and annotate it and annotate it in order on that annotation, and then get the results directly when your function returns. So this is very helpful because then you can arbitrarily do a lot of things which will be very expensive to do in Python. So yeah, you can do things like calculations. It'll be good to kind of explore the native functions in whatever database that you're using. So Postgres has a lot of cool things that you can use. And then you can do annotations, and all these things come as part of your native query. So the best part about this is you don't actually need to do these calculations after you have fetched the objects, right? So you save on a lot of memory, you save on a lot of time by using these custom queries. So you need to understand how the query sets work. So query sets are lazily evaluated. So it will be good to understand exactly how it's working, right? When it's actually expanding, when it's actually fetching those things. If you're serving an API, you need to tune your list and detail views. Now this is very important. So for example, if you're serving an API for a blog, let's say, then you might not need everything in the list view. Let's say you're getting a list of posts. And the post is maybe your post is a fairly complicated model. It has a lot of attributes, it has a lot of relationships and all these things, right? You don't need everything when you're showing the list, right? So, but you might need a lot of things in the detail view. So tune your resources so that you only fetch those things which you need in the list, right? So dehydrate finite data and denormalize infinite data. So if there are, so let's say for example a post has tags and a post has comments, right? So it will be good to dehydrate the tags because the tags are not going to be like, you don't know the limit. There would be a limit of something like a tag, which might be a relationship. Let's say there's a many-to-many relationship between a tag and a post. But you know the limit, right? It cannot be an unlimited number of tags. So you can just dehydrate that when you're serving that particular resource. But something like number of likes or number of upvotes, number of downvotes, so on and so forth, which you don't know the limit to, it'll be good to actually denormalize it somewhere and then directly access it, because it'll be quite costly if you do these calculations every time the post is getting fetched, right? So dehydrate finite data, denormalize infinite data. Again, this is very subjective. It depends on the kind of application that you have. And know when to switch to a full-fledged search engine like Elasticsearch or whatever is it that you prefer. So a normal course of action, after talking to a lot of people who have kind of started from scratch and then went on to build get to a point where so many users are there. So what they have done is, a common pattern that I've seen is people plug in Elasticsearch as just for search initially, and then they kind of move on all the reads on Elasticsearch. So which is a very great design pattern, to be honest. And because sooner or later, as and when your application complexity grows, you are going to need these things. So a lot of people, what they've done is they kind of migrated all their reads on Elasticsearch, on at least the list reads on Elasticsearch, and only the detailed reads and writes directly on the database, which makes sense in some cases. So scaling up your database. So whatever database that you're using, I'll be talking about Postgres here because Postgres is, most people use Postgres with Django. So use database level connection pooling. Django does application level connection pooling, but it can bite you because what I've found is it's very unpredictable at times, and I actually faced a lot of production issues due to Django not handling connection pooling really well. I'll go dig deeper into it later sometime, but you are going to need database level connection pooling. So it's so something like PG Bouncer, which actually pools all the database connections for Postgres. We just a drop-in thing that you do, and at least that thing is taken care of. And monitor all your queries. Find what's holding you back. So again, it'll be good to actually tail your Postgres logs once in a while, at least in development. And then it's good to actually set some alerts in production when your site is actually deployed. And if you're using any kind of replication like master-slave replication, it'll be good if you can, on a high-volume website, it'll be good to segregate the reads and writes. So maybe if you have streaming replication to 4 or 5 slaves, then what you can do is you can have all the reads from the slaves and just the writes on the master. There might be some issues with this depending on how you are actually executing this, but generally this is a good idea. Async all the things. Of course, Celery is awesome. Use it. Understand what your tasks need. Again, oh my God, did I do something wrong? Oh, shit. I don't know why this is not working. Yes. So, so talking about asynchronous tasks. So, understand what your tasks actually need, because sooner or later you're going to need to split up your workers. You cannot just have one node doing everything for you. As and when the number of different tasks increases and the nature of those tasks increases, as in diversifies, you're going to need to split up the hosts where you're hosting the nodes. So, because if you know that, then you can optimize the worker hosts depending on that. So a lot of things that you can configure, the concurrency of the workers, and what kind of optimization does it need. For example, if your tasks are IO intensive, maybe you want to put maybe you want to tune the hardware, put the right kind of hardware there. If it is memory intensive, you want to put the workers and configure it accordingly. And know when you need to break out of Celery. So this is something that's something very interesting that we did in the past few months. So I'll just give you a real world example of what happened. So we built a microservices based architecture for one of the components, and we were using Celery to actually handle those things. But then whenever there is this, whenever you add some tasks on top of an HTTP service which is scaling horizontally, there is so much of indeterminateness. I don't know what's the term for it. So uncertainty, lots of uncertainty around that. So what you can actually do is you need not use Celery for everything. Maybe if you figure out that, hey, this component would be better written in some other language, like say for example Go, then probably you should do that. Split it up split that Celery task from Python, write it in Go, and then if you're using, say, something like RabbitMQ as the broker, you can actually invoke those tasks from some other language as well, right? Which actually, helps you a lot, because then you're not restricted to just use Python or just use Django for a particular thing, and you can use whatever you want, basically. So because SLAs are important, you need to optimize for certainty. You cannot have, while scaling, you cannot kind of not know how is it going to scale, or what is your failure rate going to be, right? So using asynchronous tasks and kind of designing your entire pipeline intelligently, you can actually know how exactly what your failure rate is going to be, and then you can design the rest of the things around it. So yeah, so I think this was about it. Questions now? Yes. Yeah. Yeah.
Second, if I'm using Mongo,
Yeah.
if I'm using MongoDB,
Yes.
I've seen most of the libraries are not supported at this point of time. So what's the best suggestion for that?
Okay.
And third, a multi-tenant ERP, if I'm building that.
Okay.
Application level, database level, how do I kind of, scale that? I mean, should it be an application level partitioning that I should have, or at the database level, I should have each of these tenants in a separate schema using PostgreSQL?
Okay. So the first question, of course, again, it's more of a, so I think the first slide was kind of me trying to convince everyone that you should use Django. So I'm not really going to go into a flame war that Django versus Flask versus something else. But again, it's a matter of preference. It's a matter of what you feel you should choose, what you feel like choosing, right? For example, if you choose Flask, of course, you have to do a lot of things yourself. It's a micro framework, right? So you have to do a lot of things yourself. You have to use a lot of third-party libraries to do some things. But then that's again a matter of choice. If you use Django, a lot of things come with Django. So you don't have to, do a lot of headbanging, right? So I don't really have a concrete say argument to say that, hey, use Django and don't use Flask. So I think it's more of a matter of choice and a lot of other sub reasons that you might want to consider, but then again, it's a matter of preference. The second question about Mongo, right? So I have used Mongo with Django, but of course, as you said, there's no mature library for object document mapping. To be honest, if you want to have a a schemaless database as your primary database, probably you should not use Django, right? But if you want to use Django and not use ORM, then you can do it manually. You should do it manually, to be honest. And I think there are a lot of projects as well which are working on schemaless database support with Django. I don't remember the name properly, but maybe that's something that you should look at. Yes, but I think the question was like he wanted to use Mongo exclusively. So yeah, so as he said, Postgres now supports native JSON fields. So if that's something that you're looking at, maybe that's something that you can use. And what was the third question? I just completely forgot the first. Okay, I'm not aware of what it is. Okay.
Hi, I have one question. Right, if you are writing REST APIs using Django, right, and then there are we designed all our REST API using Django, right?
Yes.
So, what's your opinion regarding the managing the cache, right? Because the front end is in single page application, right? So there's a way to enable the cache at front end side, right?
Yes.
And do we really require to have cache management at server side as well?
So again, it depends. So caching is difficult. It's hard, and so when it comes to say REST APIs, you should cache the resources at you should cache on the resource level, Because just front end, I'm assuming by front end you mean the client side?
I mean, we can enable the HTTP request cache enabled in AngularJS, right?
Yes, yes, yes. You can, of course, you can do that. But then again, I think caching should be you should cache wherever you can, right? Because just caching on the client side does not shield you for it only shields you for just one particular user, right? For example, in case of say a blog post, right? You don't want to fetch that post again and again for different users. For one user, it won't be fetched again, but then we're talking about scaling, right? So it means a lot of users. So if you're just using one user, then if you just have one user for the application, then it's fine. But then for multiple users, you have to have caching on the application level as well, on the backend as well. I think that answers your question.
Yeah.
Hi, so I wanted to ask, you told that you know when not to use celery. You could call celery task from an external language which is not certainly Python. So I cannot visualize the use case for it because you need to know when to trigger a celery task.
Of course.
So how do you call within from external languages?
Okay. So so I'll give you a use case. So let's say so some component right now which you have implemented as an HTTP service, right? For example, I'll just take our example. That's something that we did. So our main code judge, the code evaluation component, that was implemented as an HTTP service, written in Go. So there's just one view function that takes a post request with these parameters, and it'll do the evaluation on the backend, as in on the server, and then return you the response, right? Now this evaluation would take, let's say, on an average 10 to 15 seconds. Okay. So now how we actually made it asynchronous was putting a celery task, and then letting this celery task handle all the failures, right? So if there was a resource contention on the HTTP service, then the celery task would retry. But then again, the problem was you don't know, you don't have any certainty on what's the failure rate going to be. So then what we did was, instead of having celery just make the request and handling failures, we converted this HTTP service into a celery worker, right? Now I know when to process this code run, right? I know when to send. So because I know when to send this post request, I know when this code run should be done. So now instead of having a celery worker make a post request, and then this HTTP service doing that, and the worker just waiting for the request, what we do is now we just queue this task from Python, from the Django backend, right? So the logic is still written here, but the failure and everything, it is being handled by the worker. I think that clarifies it.
But you're still triggering the task from Python itself.
Yes,
right?
of course.
So no, you told that you are trying to trigger it from an external language, not Python.
Yes, so you can do it. So how we are triggering this task has nothing to do with celery. It just uses the AMQP protocol and just sends that message in the format that celery understands. So you can queue this task from any language that you can. Yes, I think that explains it, right?
You two can talk now.
Yeah, sure. I am out of time.
One question.
Yeah.
I have one question.
Can I take this last one?
Actually, we are out of time.
We are actually running out of time.
Okay, sure. We can meet after that.
Sure. Thank you.
Thanks so much.
So thank you so much for that very enlightening talk on Django. And the keynote for the evening, the last keynote for today's evening is given by Terry Oda. Terry Oda gets paid to break things and tell people that they're wrong, all in the name of making open